Good afternoon, Matthews A. How are we doing? Welcome back. How was the break? Who was flat out with assignments the entire time? Who actually got to relax? Well done. Relaxing is good for you. Couple of things. First of all, Andrew is unable to be with us today. Arraries. Nice. Before we begin, of course, I presume you all know each other by now, so let's move on to what we're going to be talking about today. So remember, last time, before the break, we spoke about strings and working with strings and working with characters, reading and writing some assorted characters and text to the screen. We're going to go on more with that today. We're going to be playing around with a few of the functions we can use to do things, and then we're going to go down deep and dirty into arrays. We're going to find out how they're working in our systems. We're going to see what happens when you're passing arrays into functions and really how that whole thing works. So, a few little points of administration. Assignment 1, due tonight. Gaps. If you haven't started, you are probably in for a rude shock. If you have started but you're not quite done yet, you can do it. You can get that done by tonight. I believe in you. You can do it! And there is a weekly test due this Thursday. Lab marks for the first few weeks of labs are also out. I feel like I'm doing a monologue at the beginning of an American late night talk show. Lab marks are out. If you've got any issues with those lab marks, if they're big issues related to you think tests are wrong, post them in the course forum. Otherwise, if they're really particular to your particular case, email your tutor. Don't be afraid, by the way, to email your tutors. Your tutors are all really wonderful, friendly people. They're there to help you. And of course, there are help sessions. If you are in need of help, we will help you. Thank you. So, before the break, we were talking about arrays, and specifically of arrays of characters, yeah? Here is an array of characters, spelling out the name of our favorite lecturer. Question: what do I find on the end of a string? Good grief, it's been a week and a bit and you've all forgotten. What do I find on the end of a string, folks? I will accept both of those answers that I just heard, \0 or the null terminator. Yeah? So this array is 7 characters long, 6 characters of the text that you've assigned in there, and another null terminator at the end. All right? And of course, we know that we have this mapping of these characters to decimal numbers, or hexadecimal, whatever base you like. And if I ever find you actually using these numbers, you will be tickled until you cry. All right? So don't use those characters directly, but they are there. I can take a character, I can print it out. Yes, so here's a question, and this is a question I've seen a lot on the forum over the break. For those of you who've been asking really fantastic questions on the forum, well done. You've given us so much wonderful material to write about. But one question that kept coming up was a variation on why should we use these hash defines when we have the number? Why should we use this single quoted A instead of this number here, 65? Readability, meaning. 65 means what? I don't know. Could be the year you were born, 65 BC, just like me. Or it could be just some number 65, you won the 65th place of a marathon. Yeah. Or it could be absolutely anything under the sun, but if I use that single quoted A, I know what it is I'm talking about. I'm talking about the single quoted capital letter A, that character specifically. There is meaning inherent in that. And when we talk about the town names in that assignment, the town names have meaning with them. The time zones have meaning. The days, the months, they have meaning. And to throw away that meaning just because you don't want to type those characters, that's not good development practice. That's not going to make you a better programmer. It's going to make you a lazier programmer. And yes, most programmers are extremely lazy, but the laziness starts in how we understand and how we read and how we think about code. So this assertion here, this will pass, but its meaning, the meaning of the things we're putting in there, is lost. All right, and of course we have that ASCII values are this great big sequential table. We saw the ASCII table last week? The week before last. And if I were to grab our terminal and show you the ASCII table, you see great big chunks of it are sequential. A really cool and useful trick then might be, what if I want to read a number from the user but I don't have scanf? I can read characters, I've got Getchar, I've got fgets, I want to read in a number from the user. How might I do that? Well, there's our numbers up there, the sequential block from decimal 48 through decimal 57. I can use those to add meaning to my program. So, if I were to grab our text editor and let me have a C file. And if I hash include the appropriate things, what we're going to do is read in a character. Let's use Getchar. And, well, actually, let's do something better. First of all, if we don't have scanf, why would we have printf? They're very similar functions, so let's rewrite this without using printf. So I want to declare this as an array of characters. And so I can just declare that straight up. And now I can loop over this. What would my loop condition be? Yeah, I heard someone mutter over here. Ooh, that's a very good one. So I heard two good answers here. Let me go through both of those. Let's say int I is 0 while I is less than end of file. Now I could put that character. Message at I. And I'll do an I++. So, will this program work? Well, first of all, did you want I is less than EOF or message at I is EOF? Message at I less than EOF? All right, let's do that. Message at I is less than the end of file. What does that mean? Or does not equal the end of file? Yes. So here's a good question. What is the end of file? What is the end of file? What does this symbol EOF mean? Is it the null terminator? Collection of symbols which could be the end of input, the null terminator. So it's not going to be a collection of symbols because in C we can't really just straight up compare against a collection of symbols. We saw this, I keep saying last week for the last lecture. In the last lecture we saw that you can't just compare a bunch of symbols all at once. You would have to check each of them in turn. And it's not the null terminator. EOF's value is -1. Where are my -1 folks? Yeah, -1. Correct answer for everything. EOF is actually -1 though. EOF comes back from a range of functions when they can't read any more characters. But in this case, we just want to wait and we want to loop through, until we reach a null terminator. Because that's the end of the string and that's where we should stop. Yeah? So, let's do that. Well, message.I is not the null terminator. Then I would print out that character and move on to the next. All right? Okay, so if I were to compile this program, let me just hide a lot of that line noise there. So if I were to, who invented computers? More to the point, who invented mice? And who made them so damn annoying to use? Right. So, okay, it compiles, that's a good start. Well, it runs, and it prints out the characters we want, and then it prints out a weird highlighted % there. That weird highlighted % is, I admit, that is a quirk of my particular setup, which tells me this thing hasn't printed a new line at any point before it exited. If I was using a different shell, it would just leave that right before the prompt. Like that. Either or, but that's what's going on there. So we've printed out our string. Now how do we read in characters? We saw two functions to do this. What might be a useful function of the functions we've used before? I heard it muttered by someone. Yes! Getchar! I wish I had a bag of assorted confections to just throw at people. Yeah, so I could use Getchar. So here's a good little point to note. Getchar gets a character. So why am I putting it in an int? Yep, but I could keep an ASCII number in a character, in a char type variable. That's perfectly valid, but what's the problem with that? Can't initialize it? No, I could initialize that perfectly fine. What if Getchar goes wrong? Actually, this is something to ask yourself repeatedly. What if this thing goes wrong? Because things go wrong. This is the real world. Things will go wrong. Lecturers can't make lectures. Headphones fall apart. Getchar returns me an end of file if it can't get any more characters. Yeah? And we know what value the end of file character, or the end of file marker rather, is. There is no end of file character because -1 isn't a character. It wouldn't fit in a char. I can't do this and validly be able to work out what went wrong, because I can't compare C to EOF because this doesn't make sense at this point. I can't do that if C is a char. So instead, I have to keep it as an int. All right? I'm going to loop, and my loop condition, as you've spotted, is, of course, C is not the end of file. I can still read characters. If, while C is not the end of file, I can read another character. So remember back when we were starting to look at loops, we saw that there are 4 things you need to make a loop go. First thing I will need is some sort of variable to set initially. The second thing I will need is some sort of condition, some sort of check. In this case, C is not EOF. The third thing I need is, well, something to do. And the fourth thing is to step to the next value. So how might I step to the next value here? Could I just go C++? Is that useful? Is that valid? It's not really valid. It doesn't really make sense here because C is a character that we've read in. So just incrementing it doesn't actually help us move along to the next case because the next case is the next character we've read in. Yeah? So I need to C as Getchar again. All right? And, well, let's just see that this works, first of all. Let's just compile this. And run it. So it's now prompting me for input, so I could give it some input. It's still waiting for input. Because we're not doing anything in each step through. Every time we get a character, it's just sitting there, waiting for us. So, first of all, what do you do when your program is just sitting there, waiting for you? Well, Control-C, if your program is hanging, waiting for, or is hanging for whatever reason, say an infinite loop. But if we're doing input-output, if we're reading characters, there is a special key sequence you can send, which is not Control-C, but Control-D. Yeah? Control-D says, I'm finished writing characters. I'm finished sending characters to this program. And Control-D, well, when I try and Getchar, Getchar will actually go, oh, that was actually the end of file character. Okay, and the program will exit normally. If I were to go Control-C, well, what if I had more things happening afterwards? What if I wanted to read more characters? I couldn't. All right. So we know that we can read in characters. Let's just prove to ourselves that we have actually read in characters. And for the moment, I will use printf here, just to demonstrate that something is actually happening. We got a character %C, which has code, let's say %D. Yes, that'll do. Okay, so we're going to print out the character we read in, and it's ASCII code. So, 2 interesting things to observe here. First of all, did you notice, I'll show you that again, just in case you missed it. When I enter characters, nothing's happening. It's just sitting there. It's waiting. What's it waiting for? It's waiting for us to hit enter. By a strange and wonderful quirk of history, Terminals wait for you to enter a whole line of characters before they will send them to the program. So this is sitting here waiting for us to give it more characters or for an enter. And then that getchar will happen. That getchar will succeed. It will get me a character. So if I were to hit enter now, it gets me that bunch of characters. And I could keep doing that. And it's still waiting for me to enter all of those characters before it gives me those characters. All right? There's not really that much we can do about that, unfortunately. In 1521, I think, we talk a little bit more about how that works and how you can get around it. But for the moment, you can't really do much about it. You have to wait for the user to press enter. All right? So we've got our program. We can read in characters. But I want to know if these characters are numbers first. Yeah? So what could I do? How do I know if a character is a number, a numeric digit? What could I use to tell if a character is a numeric digit? But we're not using scanf. Yeah? Yeah, well, I mean, that's what we're doing here. The problem is the Getchar doesn't parse. Scanf parses the input you give it. Scanf extracts the digits and turns that into an integer, or a float, or a double, or it extracts characters out as a string. It doesn't do this if I use Getchar. That is inherent in the way scanf works. All right? So what could I use to tell if a number that I've entered is actually a numeric character? I could go ASCII codes. I saw a hand up the back there. I love your pronunciation of that function name. I'll come back to that in a moment. Yeah, that's one way I could do it. Let's do that. First of all, I do want to quickly mention, there are a bunch of really useful functions in the standard library that do this sort of thing. One function called this. How would you pronounce this? A toy? I call this A to I. ASCII to integer. Yeah? Although I do like a toy. I like that. Anyway, I could use A to I, but a more easy solution that doesn't require anything more than I have ASCII and I have if. If the character 0 is less than C, can I do that? Why can't I do this? Okay, so I can do that. What will happen? Because actually this will compile. It should be noted. That will compile, and it might even look like it works. But what's actually happening there? What's happening here is we're doing 0 is less than C. We do this first part of this expression. And then with the result of that, I go, is 0 or 1? The 0 if it's false, the 1 if it's true, is that less than 9, the ASCII character? That will compile. It will look like it works, but it doesn't. It doesn't do what you expect. If you've programmed before in a language where that does work, what on earth? Why would you even? No. Much better. If we're in the range 0 to C or C to 9. Yeah? One thing that I like to do by a point of style, and one thing that I think is really quite useful, it's really quite obvious when I'm looking at this that this is a range. I'm seeing where the C is in the range 0 to 9. Yeah? This, of course, does mean the same thing as C is greater than 0 and C is less than 9. But this is less obvious in the fact that it's doing that range. It's not as clear to me, a lazy programmer, that I'm seeing a range here. The laziness here is in what I'm understanding, how I'm understanding the characters that are there on the screen. Yeah? So we don't want that. We want to do a range operation. And sometimes you will hear this, the bit where I've reversed the thing I'm comparing against and the thing itself. You will sometimes hear this called Yoda code, because it's backwards. Use the source, you must. Actually, quite a famous little joke in programmer circles. Use the source, Luke. Okay, so if it is in this range, then it's a digit. And we could do stuff with it. So let's just move this down here, whoops, down to there. And say, oh yeah, we got our character. So that, whoa, stop that, stop it. There we go. So this gets us our character, but now I want that as a number. So how can I turn this character between 0 and 9, the ASCII character 0 and 9, how can I turn that into a number from 0 to 9? %D, once again you're still thinking of scanf there. I don't want to use scanf for this. How can I do it? What if I just take my character and I subtract 0 from it? And I don't mean like this, I mean like this. I take my character, I subtract 0 from it. The distance this character is from our character 0. Because remember, look at our ASCII table. When I look at my characters, good grief, this mouse is terrible. When I look at my characters from 0 through 9 here, the 9th character, the character for 9, excuse me, is 9 away from the 0 character. Yeah? And that's actually how tools like scanf might do that. And now I could print out that we got this number. Let me just move that there, like that. All right? So, just to recap, we've got our character, we're going to print it out as a character, then we're going to print it out as a number. These things should be the same. Yes? Whoops. So, let me first of all give it some characters. It's still sitting there. We've hit enter a bunch of times. It's still not doing anything with our input. So what about... Ooh. Well, that did it. It sees that we've got the character 1, subtracts that 0 from it, and now we are left with the integer, the number 1. All right? So we've got this far, but we can go further. We could actually put that number back together. Yeah? How could I do that? Well, let's read that number into an array first. And then we'll look at that in an array. So, if I say we've got an array of numbers, and we'll say we can only read in, say, 8 numbers at a time. And I'll say all of those numbers are 0. Now, oh, and I'll reset I so I can use that as well. Now I can write into the ith place in the array. Yeah? So what we're doing here is we're taking that character, turning it into a number, putting it into that array there of integers. Yeah? And we'll do I++ and go to the next character. All right? And now, of course, I could go through the numbers that I've read in and put them back together. Yeah? So how would I turn the numbers 1, 5, 1, and 1 back into a useful integer like this? Putchar. So that will only let us see those characters on the screen. Once again, what I want to do is I want to take these numbers now that I have and I want to stitch them back together into an integer which had the same value as what we have there, what we've entered. So I know what character I'm up to, and I know what its value should be. Yeah? So I take a character, let's say I've got I is 0. I'll just comment that out. Whoops. So I've got I is 0. Now, what do I want to do? I'm going to go through each of the values in this array. I see a magic number, I'm going to pull that out and make that a hash define. All right. So I have this. What do I do now? I can go through and, well, I could print out these characters, of course. Let's just use putchar and dump these characters onto the screen for starters. Numbers at I. So let's see what that does. Remember that we're just printing out the numeric value 1, the numeric value 5, the numeric value 1, the numeric value 1, and also a bunch of zeros. Where do they go? Where do they go? Where did these characters go? Because we've just printed out 4 characters to the screen. They are being printed, yes? So where did they go? We've printed out the character 1, of course. I mean, that's where they went, but we've printed out the character 1, which up here is called SOH. I have no idea what that does. We've printed out the character 5, which here is ENQ. I have no idea what that does. And we've printed out a bunch of SOHs again, and we've printed out null. Not particularly useful. So we would actually need to, if we wanted to print this out, undo this by adding 0, the number 0, back on. Yeah? So if I were to do that, then I'll get back a bunch of numbers. Except for one small problem, which is I've still printed out a bunch of zeros there. So how could I not print out a bunch of zeros there? Null terminator? Yes, but how do I know where to put the null terminator? Well, actually, let me start with this. I know that I have this in an array, and I know that I currently have I equal to, I don't know, 4 or so. So could I not just come up with another variable and use that to loop instead? while j is less than I, I'll do j++. Yeah? So we're going to loop over our array starting from 0, going to 1, going to 2, going to 3. We reach 4, we stop, but at this point, all of the numbers we ever want to print have now been printed. There they are. All right? But if I wanted to turn these back into a number, what would I need to do? Yo. Yeah, that's exactly how you do it. The problem with that, though, is that means I need to know how many numbers I have anyway. I could do this somewhat better, though, by keeping track of where I'm up to and only multiplying by 10 each time. Yeah, ooh, I like that. 10 to the power of thing. How do I do, just out of curiosity, because I'm sure a few of you have asked or seen this question on forums, see how good your memory is, how do I take the power of a number in C? Yeah. Yeah, I'd have to slurp in the whole maths library, because C doesn't support carets for power. This is not 1,000. Actually, what is the value of this? Yeah. Let me grab that, chuck it in a program. What is the value of 10 to the 3? It is an integer. It will be a number. Good file name, good file name. So what do we think this is going to produce? Ten to the 3, or 10 caret 3, won't produce 1,000. It'll produce, good grief, 9. Wonderful. So that's clearly not a power function. So another way that you will sometimes see languages do it is just slap some stars up there and yeah. And this will of course say, oh, scary error message. So that's clearly not what we want. So yeah, you do actually have to use the pow function, which lives in math.h. And if I want to use it, of course, I need to also provide -lm when I'm compiling. Actually, I may not have to, but certainly it's a good idea to do so. And there is 10 to the 3, it's 0. What? That's not right. What's going on here? For those of you who've been actually paying attention, you would have just spotted the words floating point values happen somewhere in this compile error. So let's print out this value as, say, I don't know, an LF. Okay, that's interesting. Why? Why has this happened? Because power returns us a floating point value. Because the power of an integer to another integer is going to be significantly bigger than anything that I can hold in an integer. Yeah? If you don't believe me, pester a maths lecturer until they prove it to you. So power returns a float, not particularly wonderful for our purposes. So let's try this without doing power operations at all. Let's just multiply by 10 each time. And we'll start with our sum being 0. And we will do, instead of this putchar, we will do sum is also numbers at j times 10. Yes? No? What we want to do is we want to take the number we've got, move it over by a place, and then add our value to it. So we'll move over our value first and add our value. And now if I were to print this out at the end, as a %d, because this is an integer now, so back to that. Looks good to me. And of course, because this is now just a valid integer that I can manipulate, I will add, say, 10 to it. And of course, I will forget to compile, because I always do that. And I get another number. All right? So this is how I might conceivably take a bunch of characters, read them in, and turn them into a number. Yo! Yes? Could I use the round function? Yes, but it's usually a bad idea to deal with floating point numbers in general. Unless you absolutely... because floating point numbers are imprecise. Floating point numbers are usually not a good idea to play with unless you need to deal with them. In practice, floating point numbers are imprecise. And there's a few weeks of that in a maths course and also in 1521. All right? So, we've talked about this with Getchar. We've got a couple of other functions we can use to do this. In fact, we've got one other function I can think of to use to do this. I want to read in a bunch of characters into an array. How might I do that? I mean, yes, using this approach here. Yeah, I could do that. But we've already done this. I want to do this in a different way. Not using scanf. Still not using scanf. We've got another function for it. We saw it at length in the last lecture. Ooh. I like the way you're thinking, but no, not in this particular instance. Fgets, yes. Actually, I heard you say two names of functions there. One of them was gets. And for saying gets, your penalty is the loss of your tongue by saber. Gets, you must never, ever, 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 ever use. Do not ever use gets. If you use gets, I will haunt you forever. Fgets, however, perfectly safe, no risk of haunting. So if I were to use fgets to do this, what do I need to use? What do I need to do to use fgets? I need three things for fgets. Anyone remember what they were? I heard a few people say array or string. Yes, I'll need one of those. I will need an array size and I will need a stream. Yes. So fgets, remember, takes an array of some sort, or a buffer if you prefer. It takes the array size and it takes a stream. All right? There are actually a few streams that you can use in your system, and when you open a file, you will get a new stream that you can get from and print to. But if I'm just fgets, I'm doing fgets from the terminal, I use the standard in stream. So I would fgets into my buffer or my array. My array is, say, n numbers, and it will be from the magic stream name standard in. All right? So, I'll need to declare an array, won't I? Char array is n numbers. All right. Okay, so we posed a question earlier. What happens if this thing goes wrong? What happens if fgets goes wrong? How do I know that fgets has succeeded? No? No one? So fgets actually returns a magic name. It doesn't return EOF. Fgets does not return EOF. Fgets returns a magic name, a different magic name. There are so many of the damn things. It returns the name null. And we'll start seeing this name a lot in the next the next half of this lecture actually, and over the next week or so. But it returns this magic name null. Yeah? And that tells us that it hasn't succeeded. And I would need to deal with that, but for now, we'll ignore that likelihood, which you should only ever do after you've at least considered that it could happen. And once again, I now have an array of numbers. And I could print this array out. So what does fgets do? Fgets reads a bunch of characters from a stream into an array up to a size. What else does fgets do? Fgets does two really nice things for us. Well, let me pose you this question then. This array, is this array a string now? Who reckons this array is now a string? Who reckons it's not a string? What makes an array of characters a string? There is but one thing that makes an array of characters a string, and it's our good friend, the null terminator. Yeah? Fgets makes sure that that array will be null terminated. Therefore, that array will be a string. Hooray! Fgets also does another thing, which is that it stops reading characters from the stream when it sees a new line. Yeah? So, if I were to take this program it will, of course, behave as I would expect. It stops reading when it hits that new line, chucks the new line, and a null terminator. It puts both of those characters into the array, and everything is wonderful. What if I give it more characters? It will only read as many characters as it can. In this case, only 7, because n numbers is 8, and it needs a character to leave that value, that null terminator in. All right. I think that makes a good little summary of strings. So let's take a break. Let's take a 10-minute break. Make sure you stand up. Make sure you move around, because after the break, we're going to talk about how arrays work and how they're passed around in our programs. So that's coming up after the break. Hello, welcome back. Let me stop that incessant rubbish. And let's step through this to get up to where we want. We've seen that. Okay. So, up to this point, we've really considered arrays, we've considered integers, we've considered that there is data floating around in our system, but where is it? Where is that data? If you remember, let me see if I can make this work. If you remember from back in the good old days, when we saw our variables for the first time, thank you. As you remember from the good old days, when we stored a value, what's actually happening is we're setting aside a box to put that value in, yeah? So I have my value, let's say, I don't know, 5, and that actually just sits there in that box. And I'll say this is an integer-shaped box, because why not? And so I have here my value. Yeah? And then remember, when we have an array, what's happening is I have not just one box, but multiple boxes in memory, all set right against each other. So our first value might be 1, 5, 1, 1 there. And here I have an integer array of 5 values. Yeah? But here's the question, where are these things? Are they just floating ominously in this white void of my page? Well, no, actually, they're not. They are floating in memory in a very particular, well-defined way. And they're effectively all sitting in a larger box. Specifically, this is the box for main. Yeah? This is where main can do its working out, its rough scribbling and so on. And what we call this is a frame, or a stack frame. And the values in our stack frame here live as long as, I keep pointing at the wrong screen, live as long as main is happening. And in most of our programs, that's for the duration of our program, because main is our main function. But if I want to consider the situation where I have multiple functions, each of those functions gets their own stack frame. So if I were to come down here and show you, say, once again, a stack frame for main, and I will say, in our stack frame for main we have, I don't know, let's say an array of however many things that is, and I'll put some values in it. There's our 8 values. If I want to pass this into a function, what happens? Well, we can't just take, well, with a normal function rather, if I wanted to pass, let's say, this number 5 into a function, that just gets copied. Yeah? If I have a program, ooh, pretty. If I have a program that has int main, int I is, say, 5, int j is an array of 5 things, being 1, 5, 1, and 1. If I have this, if I were to pass this I into a function, say f, because I'm really bad at naming functions, when I pass I, the value in this box here, the value 5 in that box there is copied. It doesn't move. I don't give f, whatever function that is, a copy of that value. And so if I come down here and I'll put, I'll just make this slightly larger and add some more room to it. And I will put that 5 back into my frame. If I were to call f now in f's frame, there is kind of a hole in it. And into this hole, into this box-shaped hole, that's where we copy that 5 that we pass in. Yeah? So this 5 here would get copied up to here. But these are 2 separate 5s. They are not in any way connected. Yeah? This 5 that I have passed is copied. It does not hold any meaning in f with respect to main. Yeah? We happy with this so far? So we've seen that this happens, and we've seen these things get copied, but what happens if I want to pass an array? The problem with arrays is that they're not simple. Arrays are complex. Arrays are big and hairy, and they're more than one box, and we can't say, here is some arbitrary number of boxes that are ready for us to copy some array into. So I can't just leave a hole in F that's big enough for whatever array size I'm going to come along and give it. Because I don't know how big that will be. How big is an array? I don't know. So what instead we do is we say not that we copy this value, but that we pass a reference. Yeah? In this case, what's happening, what will happen rather, is that the value in here is a special value that says, actually, no, this is this array down here. It is not a copy. Every other value, every simple value, integers, floats, doubles, characters, they will be copied, but arrays, you cannot copy them. They are complex, they are big, complex enough and big enough that we just can't lump them into someone else's stack frame without them being ready for it, and who's ever ready for just having that lumped on them? So, we pass a reference. Yeah? So what does a reference look like? That's an interesting question. What if I take all of memory and I pretend that down here in memory I have where main stack frame is, and in here I have this value 5, and then I have these values 1, 5, 1, 1, 0, 0, 0, 0, all over there. If it's in memory, I know where it is. It has a location in memory. I can talk about things in memory by their location. Yeah? So let's say then that this frame for main, this location in this frame is at address, I don't know, 100. And this location in the frame is at address 200. Now here's an interesting fact about arrays. All of the addresses within an array are sequential, because an array is just a bunch of values all sitting end to end against each other. So the address of the first thing in this array, this 0th value, has address 200. But our first value has address 204. Okay, where did that 4 come from? Quick side note. How big is an integer? I hear 32 bits, I hear 4 bytes. Yes. And that is why this is 4 bytes. It's because to have an integer and then another integer past it, the integer past it, if they end to end, will be 4 bytes. If this was an array of doubles, my first address might be 200. My next address would be, how big's a double? I hear the address I'm looking for. How big's a double? 8 bytes. It's double the precision of a floating point number, and a floating point value just by itself, or a float rather, just by itself is 4 bytes. A double is 8 bytes. Yeah? So if this was an array of doubles, it would be 200, then 208. All right? And the addresses just continue on in this fashion. So here would be address 208. Here would be address 212. The problem with addresses, though, is in decimal, they're a bit meh. We usually talk about addresses, these references to a value in hexadecimal. Yeah? So this address might be OX 200. This address might be OX 204, OX 208. But this 212 won't be 212. It would be, any guesses? 208 plus 4, but you have 16 fingers. $200 Yep. So these addresses, everything in memory has an address. These addresses are a little bit simplified to make it a little bit more obvious what's going on. So when I were to call f in f's frame, it's going to have its space for the value 5. That 5 is just going to be copied. Yeah? So I'm going to wind up with 5 in this box up here for I. But for this array, what I'm going to wind up with is a box containing a reference to that array, to the beginning of that array. Yeah? The array operations do these additions for you, do the additions of addresses here. The array operations let us take a reference to a thing in memory and pick values. So if I were to come up with a function void f, which takes an int I and an int j, and for each of those things, I have picked terrible names because it takes an int and an int array. Then what will happen? If I were to print these out, as decimals, because they are, what will happen here is I will just print out a sequence of these values. Yeah? The sequence of these values as they sit in this array in memory, working our way from 1 to 5 to 1 to 1. Yeah? This is really weird. I will say this. This is quite weird if this is the first time you're seeing this idea. All right? Let me first of all show you that this works by changing num here. I'll change num to something absolutely ridiculous. And I'll print it out. I should come up with better names. Names are good. I'll print out num, because it's %d, I can print it out as %d, and it's just num. Okay. and I will remember my hash includes. Okay. So if I were in this function to change num, I'm only changing this value up here. It's not in any way tied down to this value down here. Yeah? So if I were to compile this and run it, I will print out my values and num is 5. Remember, I'm printing out num in main. Remember that 5 is copied from main. It's copied from main into the hole in that stack frame that is there waiting for our number. It doesn't change the value below it. But what about arrays? Because we're passing arrays not by value but by reference, if I were to pick a value in this array, say the 0th value, and change that from 1 to, I don't know, 17, and now if I were to print that value out in main, array 0, we know it starts out as 1. If I change num in F, it doesn't change in main. If I change array 0 in F, though, it changes in main. Because there aren't two of this array hanging around. There's only one of them. There's only one copy of this array, and it's here in main. Yeah? When I pass this as a reference into my function, I am not passing the array. I'll keep saying that because it is really, really strange. For all values that are simple, which we can copy, we copy them. But for values which are not easy to copy, like arrays, we can't copy them. We pass a reference instead. Yeah? So, if I were then to, let's say, grab, where is it? This example here, where in my main, let's say, I have, let me pause that for a moment. If I have in my array, in my main, excuse me, in entiles, in hentiles, excuse me, as entiles, and then I can read them in, I would read them in that function. I've passed a reference to this hidden tiles array into read tiles. And in read tiles, it is perfectly able to modify those values. And again, in print tiles, same thing. And again, in test fanakal AI, same thing. You can see those values. You can even change those values, but probably shouldn't under all circumstances. So, we know that everything is in memory. And we know that the reason everything's in memory, and why that's nice, is it means that we can set up these references from in a function to a value that is stored somewhere else. Yeah? Even your program is sitting in memory, and you could poke in. And we've talked about this as well. Variables in a function, when I have that variable in a function, if I were to come back down here to my example, I've explicitly passed num and array into this function. These values don't live beyond main until I pass them into this function. So if I were to say, this function is actually void, well, C says I don't know about these names, but more importantly, I can't see those values. It is not possible for me to see the values in main. All right? Computers. So we've got a copy of the value. Arrays work by passing values. So what I want to do now is I want to show you a little bit more about what's happening and what if I wanted to change num? What if I want to change num in my function? With arrays, something is happening such that when I pass an array into a function, it is making a reference implicitly, automatically. We don't have to do anything for that to work. But if I want to actually change things, then I need to explicitly create references to those simple things. Otherwise, those simple things can't be changed. Yeah? Because they'll just be copied. So let's say I want to return the sum. Ordinarily, I could just work my way across this array and add together all the values in it. The sum plus equal array at I, array at I, and then return sum. But what if I want to return multiple things? What if I want to return not only the sum, double average? I want to return the average of these numbers. Well, again, I have to sum them all up, and then I divide my average such that it is sum divided by the number of values. But one of those needs to be a double, so it works. I want to return two of these values from an array. There may be from a function, excuse me. There may be a perfectly valid reason to do this. I could return an int just normally. I could turn this function into an integer function, and then it can return sum. But what if I want to return average as well? It makes no sense for me to loop over this function multiple times to work out the sum and the average. So what I can do is say, I want to pass a reference to a simple value. I want to pass a reference to a double. And by the miracle of good naming, I have carefully made sure that all fits on a line. Once again, I have to change my prototype. Takes a double average. And now I need somewhere to put it, so we'll say double average. Now I'm going to pass, let me keep both sum and average. I'm going to print out my sum, I'm going to print out my average before we get into the, before I get into that function proper. So I'm going to print out my sum, it'll be, and my average will be of type long float. So how do I now pass this reference to average? With sum, it just comes back to me. It comes back because the function returns a value. But with average, how do I make that come back to me? What I have to do is now raise us up to a new level of types. Remember that in C, we have all of these types of values. We have int, we have double, we have char. But we also have, and you've seen a couple of these floating around, values with a star. We saw in the last exercise, well, in fact, even down here, I have double star. And all that means is a reference to a double. Yeah? Doesn't mean the double itself, it means a reference to the double. So how do I use one of these references to a double? Well, it turns out you've been using reference notation for a while now. Because one of our favorite functions, when I want to use it, I have to give it references to things I own to write its values into. So if I were to, I don't know, whoa, come on, like that. There we go. If I were to be in my function main, and I have a few variables, in main, and I want to read values into them from the user, I call one of my favorite functions scanf. And if I were to call scanf on this I and this j, what would I do? I would say ampersand I, scanf some %d into ampersand I. I would say, good grief, you can delete things? Lovely. I would say scanf %d into the address of, the reference of I. Yeah? Because otherwise scanf doesn't have a way to give us that value back. Scanf just doesn't know where this I is to be able to refer to it, to write that value into it. Yeah? So, this might suggest then that in scanf stack frame, yes, it has holes so we can poke in these values here, but it suggests that we could use the same syntax in our own code. So, let's have a look at how we would do that. So here, instead of passing in average, I'm going to pass in a reference to average. I'm going to take a reference. So my double now has type double star. And this seems not particularly useful. Once this double star is on a value, I now can't do anything to this value. And this value, because it's a simple value, references in C are simple, arrays are not, which is why we pass references, I can't do anything to average in this way. I still won't have changed average. And if I were to compile this and run it, if I were to compile the right file, when I print out my sum and I print out my average is still 0. The 0 I left it as. So how do I do something when I've got a reference to a value? What I need to do is I need to add a new piece of syntax. I have a way to take a reference, so now I need a way to reach through that reference. And the way I do that is with this beautiful, magic, wonderful piece of syntax, star. Star isn't always multiply two values together. Yeah? In the same way that minus isn't always subtract this value from this other value. In a binary context where there are two values, then yes, that's what's going to happen. So if I take 1 minus 0, yes, I'm going to get 1 minus 0. But if I say minus 1, that's a different context. That's no longer the binary context of the minus operator. It's now the unary context. It's now negate. In the same way, star in the binary context is multiply values, but in the unary context, it is dereference. So we have this pair of operators now. Our pair of operators, they are ampersand, which takes a reference, and we have star, which reaches through, or it dereferences. And with these operators, I can now reach from a stack frame where I don't have a value, but I have a reference. I can now reach down and pass back values. So now I'm using dereference here. I can assign to it. Let me just show you what I mean here. By printing it out, I'm going to print out LF average Average is LF average. And let's say I also want to, yeah, let's do that. What I've now got, oh, excuse me. What I now want to do is I want to say average gets a value, but now I want to pass this value back. I use star average. So in the same way, I can print this out, right? No, because this now gives me a compiler error. And now we're actually going to pay attention to this compiler error, and you may have seen it a few times, which is format specifies type something, but the actual type is something star. And what this is saying is there's a reference there. You can't do anything because that's a reference. I can't deal with a double as a reference. Well, actually, I can, and the value I get is amazingly 0, which isn't particularly useful, but we actually do have a way of printing out the location of a thing, which is using %p, and that will print out that reference. And it says, here is the location that we are referring to, and if I were to now dereference this in my program, both before and after I've changed it, we're going to see that its location doesn't change. The reference we're holding does not change. But when I look at the actual value it holds, now it does change. The reference is the same as before, but the value now changes, and the value in main has now changed. Let me mark these up a little bit better. So in main, we have our sum, we have our average. That average has been passed back not as a simple returned value. The returned values also sit in the stack frame. They also sit in holes in the stack frame. In the same way we poke a value into the stack frame saying, here is space for an argument, we have space for the return location. In the same way, I can construct my own references, my own ways to pass into another function a value. Yeah? So, I've taken a value here, I've taken a reference to it. What's actually going on here? Let's have a look. That's not the button I wanted. Stop that. Come back here. So if I were to look in main's frame, let's just have a look at the code for main for a moment. Here is main. I have num. I have my array containing some 5 values, and I have average and sum. Average and sum are uninitialized. We haven't given them a value when we declare them. Average, most notably, that's the case. Sum, it's a little bit less obvious that that's the case. We are still declaring and assigning, but when we declare, it doesn't have a value. It's uninitialized. The initialization occurs because I pass f, a function, some information. So I pass into f from main, because that's where I am here, I pass into F some values. Those values that I'm passing into F are, come back here, a number, an array, and a reference. So in this number, the number 5 just copies straight up, yeah? Perfectly normally, as we've seen before. Our array reference is, as we've seen before, let me pick some topical colors. Our array reference I hope the colors have made it a little bit obvious what's going on here. I have a reference to somewhere else. That's what array is. And in much this, and I'll just give them a number because there are going to be a few of these. Here's reference 1. And reference 2 points here. So what I now have is a way to get from inside the frame of F down into the frame of main. I have these holes, or yes, portals from one stack frame to another. And what I can do is I can reach through them. I can reach through this array reference that I've passed. The only reason I'm writing this array reference with square brackets is because we hadn't seen star before. In the type position, this is now a reference type. That is all an array in a function argument is, a reference. So when I have array, what I'm doing is I'm reaching through my array to location I, where I is 1, where I is 2, where I is 3, etc. Yeah? Does that make sense? Okay. So once we've gone through in F, we've worked out what our sum is. Our sum and our average, well, we know the average is, 1.6. Our sum is 8. What I now want to do is I want to pass this average, this 1.6, down, back to main. And in exactly the same way that I can reach through a value that I'm holding, I can pass this value back down by, again, reaching through and writing down here 1.6. By reaching through this reference, I can place a value there. All right? And then F finishes. F finishes, I wind up with its value coming back into 8. All right? So this is all rather convoluted. So let's have a look at this with a much cleaner and simpler example. So once again, in main, I have some integer I. I also have some integer j. Where are I and j? How can I find that out? I have a way of saying, let me just save this first. Let me save this without making a typo first. I have a way of saying where a thing is referring to. Let me just pause that again. The way I have for saying where a thing refers to is by asking for a reference to it. Remember, my reference I take by saying ampersand something. Ampersand I. And instead of scanning into that, I'm going to print out where that is. but not using %d or %lf. I'm going to use %p. %p for reference. It actually has a slightly better name, but I'll save that for a moment. I'm going to print out the reference I. Now, I can't do anything with the value in I. I can't dereference this because it's uninitialized. If I were to pass this reference, it would still be uninitialized. If I were to set this to, say, j, it would still be uninitialized. Where is j? Let's see. So let's compile that and run it, but I'll run the right program. There you go. So here's an interesting thing about these references. These references are roughly sequential within the frame. Within main's frame, let me turn that back on. Oh, dear. Within main's frame, would help if I remembered what I was doing. There we go. Within main's frame, I have I and j. And according to this, they're located roughly sequential to each other. One's located at address blah EF0, and one's located at address blah F00. All right? But now I can manipulate these. Once I have a reference to a thing, I can now grab that reference and hold on to it. And now I can do stuff with this reference. First of all, I know where it is, so I can print it out. But I can also assign its value. But I'm going to dereference it when I assign it. So what I now have, looking back at our stack frame of main, is instead of just I and j, I also have my reference to main. And it is once again just pointing down here. And I can write through that reference to a thing, so I can now set this to, I don't know, 5. I'm particularly imaginative. And now I can print it out. It's an integer again when I dereference it. It's just an assignable integer when I reach through it. Remember, its type is int star. When I use ampersand, I add a star. When I use star, the operator, I remove a star. So I have here star iref. By adding the star here, I have made this an actual integer that I can talk about, and I can print it out. Question, now I've done this, what's the value in I? I is now initialized amazingly. Because remember, I've reached through a reference that points to I. I've reached through it, I've set it to have a value, so I and iref star are now both 5. All right? So, let's wrap it up there for now. Tomorrow, hopefully, we'll have Andrew back. And tomorrow we'll play around more with these references. Remember, assignment due tonight, weekly quiz due Thursday.